Hello all, welcome back. I'm here today with a video on chemical bonds. That is the connections which hold atoms and ions together to form molecules and crystals. Now there are different types of chemical bonds which we'll talk about during the video, but then we'll first look into what exactly is the basis of bonding. Why do atoms associate with each other, to form bonds or to form particular type of bonds? We'll also look at the differences between polar and non-polar molecules, which is a very important question that can be asked in your exam. When two atoms come together to form a bond, it is characterized by the octet rule. Octet rule says that each of these atoms is trying to fill up 8 electrons in their outermost shell, which is also called as the valence shell. So if their valence shell has a total number of 8 electrons, then it is a stabilized configuration. Now, there are exceptions to this. For example, in case of hydrogen, the maximum number of electrons in the valence shell is only 2 and not 8. Or you do have transition metals which show an expanded octet. That is, they do not have 8 as the maximum number of valence electrons. They can have more than that. But for most of the elements, the rule is that if it has 8 electrons in its outermost shell, then it is in a stable configuration. Now, to achieve this 8, these elements can either lose electrons, gain electrons, or share electrons from another atom. Which of these options it is going to choose is based on the electronegativity of that atom. So based on the electronegativity, the atom decides whether it's easier for it to lose electrons, gain electrons, or share electrons. Electronegativity can be defined as the tendency of an atom to attract electrons in a molecule. So when it is bound to another atom, if it is able to pull the electrons towards itself, then it is termed as a highly electronegative element. Now, when two atoms come together, if the difference in their electronegativities, so I have two atoms that are close to each other, they are forming a bond, and if the difference in their electronegativities is more than 1.7, if it is more than 1.7, then such elements tend to form ionic bonds because their electronegativity is so different that they are able to get ionized completely. If the electronegativity difference is between 0.4 to 1.7, then such elements usually form polar covalent bonds. So it's a covalent bond. We'll talk about what polarity is. One of the elements is pulling the electrons more towards itself, but it's not enough to ionize the elements or to ionize the atoms. So based on the electronegativity difference, we have ionic bonds, then we could have covalent. Again, under covalent, we have different types. And for all of that, we need to remember that electronegativity difference is very, very crucial. So the major three types of chemical bonds are ionic, covalent, and metallic bonds. Ionic bonds are an example of electrostatic attractions. Electrostatic because here two atoms are attracted to each other due to their difference in charges. So we have one atom which tends to lose electrons and form a positively charged ion. So in this example, if you see atom 1, which is A, is losing electrons to form a positively charged cation, that is A plus, and B is waiting to grab the electrons. It's more electronegative. So it is taking up the electrons that are lost by A to form a negatively charged ion. It has taken up an electron, so now it has an extra negative charge and it is termed as an anion. Now when these cations and anions come together, you get an ionic bond is formed and you get an ionic molecule. Why did they come together? Because we know that opposite charges attract each other. So ionic bond is usually seen between a metal and a non-metal because metals tend to lose electrons and non-metals tend to gain the electrons. The electronegativity difference is very, very high between these two. We then have covalent bonds. Covalent bonds are where the atoms are sharing the electrons. There may be a difference in their electronegativity, but not so much as to ionize the element. So the ions are not formed. Instead, one or more electrons are being shared between the two atoms. So when you have sharing of electrons, that leads to the formation of a covalent bond. This is usually formed between two non-metals. But again, you have two types of covalent bonds that are formed. We could have a polar covalent bond or a non-polar covalent bond. A polar covalent bond is where the electrons are unequally shared. So one element is a slightly more electronegative, so it pulls the electron cloud more towards itself. That's called as a polar covalent bond. And a non-polar covalent bond is where the electronegativity difference is not much. So the electrons are being equally shared between the two atoms. That is what we would term as a non-polar covalent bond. We also have metallic bonds. Metallic bonds is where there's a very small difference in the electronegativity between the atoms. Here, the atoms which take part in metallic bonds are metals. So metals will form, if you can see over here, they'll form this kind of a structure where they lose the electrons to form positively charged ions, but the electrons are not lost to another element. They are present around the positively charged ion itself. So you basically have a sea of electrons around the positively charged ions. This is termed as a metallic bond. Now, how do we identify whether the covalent molecule given to us is a polar covalent molecule or a non-polar covalent molecule? For that, we need to know something about dipole moment, which is seen in the molecules. Dipole moment is basically a measurement of the separation of opposite electrical charges. That means the separation of a positive charge and a negative charge. That measurement is what we call as a dipole moment. Now, one example I can tell you is HCl. So in hydrochloric acid, you have hydrogen and chlorine. Now, hydrogen is less electronegative than chlorine. So, because of this, chlorine pulls the shared electrons more towards itself. Though it's a covalent bond, chlorine pulls the electrons more towards itself, due to which it now gets a partial negative charge, which is written as delta negative. So, this delta negative shows that chlorine has a partial negative charge, whereas hydrogen has a partial positive charge. And if you see how the dipole moment is shown, wherever you have a negative charge, the arrow is towards that side. The positive charge is shown by a line. So you can remember this by thinking of plus sign or the positive charge, which is where the line is. Now, in this example, in HCl, Cl is highly electronegative. That is why it's having a concentration of the negative charge around it. So the dipole moment is in this direction. Now, this is one example of a polar molecule. Why is it a polar molecule? Because one of the atoms is pulling the electrons more towards itself, which means there is polarity. One end is, one of the poles is positive, one of the poles is negative, and that is why this is an example of a polar molecule. How do we identify polar molecules? One way to identify polar molecules is if a molecule lacks symmetry. If there is no symmetry in the molecule, that is a given that the molecule will be polar. Or another example of, or other easy way to find a polar molecule is look for a hydrogen that has been attached to either an oxygen or a fluorine or a nitrogen. These are, the atoms which are highly electronegative, and if they are bound to hydrogen, then such molecules are usually polar in nature. So I could give you example of, say, H2O, where hydrogen is bound to oxygen, or we have example of hydrofluoride, hydrogen and fluorine, where you have fluorine which is highly electronegative, or NH3, again where you have the nitrogen which is more electronegative than hydrogen. An organic molecule that I could tell you could be, CH3NH2. So methyl hydrazine, as you can see over here, the hydrogen is bound to nitrogen. So this is an example of a polar molecule. Or CH3OH, this is also an example, or CH3COH, acetic acid. All of these are examples of polar molecules. One easy way for you to find out is if the hydrogen is attached to oxygen, fluorine or nitrogen, definitely it's a polar molecule you're looking at. Or if the molecule lacks symmetry, then it is a polar molecule. Now, if you see here, I have shown you what is the meaning of lacking symmetry. So we have water molecule over here, H2O. There is a net negative charge on oxygen, partial negative charge on oxygen, because oxygen has two lone pairs of electrons and it tends to pull the electron cloud towards itself. It is highly electronegative. So you have the net dipole moment in this direction. That's why this blue arrow has been shown. So there is net dipole moment in that direction, and that is why this is an example of a polar molecule. Non-polar molecules are those where the dipole moment cancels out. So you can see over here, I have carbon dioxide. Though there is an electronegativity difference over here between carbon and oxygen, it's equal in both the direction, and so it cancels out. So this is an example of a non-polar molecule. Or we have, boron trifluoride, where I have boron and fluorine. Fluorine is highly electronegative. However, the dipole moment in all the three directions cancels out, and so this is an example of a non-polar molecule. Or we can have carbon tetrafluoride. This is again an example where all the four sides the fluorine is present around carbon. So again, the dipole moment cancels out. So if all the dipole moments are in the same direction, then it doesn't cancel out, like how it's shown in the case of water over here. If they are in opposite directions, then they usually tend to cancel out, and thus they form non-polar molecules. Now let's do a few questions based on this polarity and differentiation between polar and non-polar compounds. You can always pause the video here and try to solve each one of these and then restart the video to listen to the answers. So if you see the first question, they have given you different bonds and they're asking you which of the following is the most polar bond. What are the characteristics of a polar bond? It should be lacking symmetry, or you should have hydrogen which is attached to a more electronegative atom. Now in all of these examples, or most of these examples, hydrogen is bound to a more electronegative element. So we now need to identify which is the most electronegative of the ones given here, and hence which one would be the most polar bond. Now why I did not consider carbon-carbon at all is because both atoms are same, which means there is no dipole moment at all. Neither of them are more electronegative than the other. Of the remaining ones which are given over here, the difference, the electronegativity difference between hydrogen and oxygen is the most, which means this is the most polar bond that has been given amongst the others. In the second question, they have given you different examples and different pairs, and you are asked to identify which one is the more polar of each of these. So if you see here, we have hydrogen which is bound with two halogens, but then fluorine is more electronegative than chlorine. So the answer here would be HF. Between NO and CO, we know that the one which is having more difference in electronegativity with oxygen would be carbon. So the answer here is CO, or carbon monoxide. Between SH and OH, O is the one which has more difference. So the answer is OH. That bond would have more polarity. Between PCl and SCl, phosphorus and chlorine have more difference in their electronegativity. So this is the answer over here. Between CH and NH, it is NH which have more difference. N and H are much farther away from each other, so that would be the answer. Between CO and PO, again, it is phosphorus which is having more difference. And the last one is really easy because NN doesn't have any electronegativity difference at all. So the obvious answer is CN. With that, we come to an end of today's video. Hope you all were able to learn something new in this video, or at least you were able to have a good revision of your existing knowledge. I'll see you all in the next video where we will discuss more about intermolecular forces, which are seen as stabilizing interactions between the different particles of matter. All right, bye till then.